using confidence intervals to determine cause and effect, an example. Sometimes we use confidence intervals of two proportions to determine cause and effect relationships between two variables. Just a quick note before we do this, when we use confidence intervals to determine cause and effect, we don't need to satisfy condition one of our conditions, which was both examples are randomly drawn from their populations and observations are independent of each other. Why? Because instead of looking at random samples, we're going to be looking at objects that are randomly assigned to groups, or people randomly assigned to groups. So as long as we have assigned people to groups in this kind of scenario, then as long as the other conditions are met, we can interpret our confidence interval for the two groups. Okay, here's our example. A study was conducted to determine which of two treatments for Crohn's disease, Inflix injections or Azath pills, was better. Patients were randomly assigned to receive either Inflix or Azath. 169 patients received Inflix, and at the end of the study, 75 of them were in remission, a good outcome. 170 patients received Azath, and at the end of the study, 51 were in remission. Let P1 represent the proportion of Crohn's disease victims who would be in remission if they took Inflix, and let P2 represent the proportion who would be in remission if they took Azath. A 95% confidence interval for the difference in population proportions is 0.04 to 0.25. Now, assume the conditions 1, 2, 3, and 4 are satisfied, interpret the confidence interval, and decide which treatment is better. Here's the thing. We're given the confidence interval for this problem, and we're asked to interpret it. I'm going to show you guys how to find this confidence interval with Statcrunch so that you have this in your tool bank of knowledge, and then we're going to do the question where we decide which treatment is better. So first of all, where did this problem come up with that confidence interval? It comes from all these numbers given here, and we did a video on using Statcrunch to do this, so this will be your second example. And so what I'm going to do is I'm going to go to Statcrunch, and we're going to find this confidence interval. So I'm going to escape full screen, and we go over to Statcrunch, and we go Stat, Proportion Stats, to Sample, with Summary. We click on it, and then we have to fill in all the numbers in this box. So we have 1, 2, 3, 4 numbers to do. So if we go back to the slides over here, we are told that P1 is the proportion of Crohn's disease victims who are in remission if they took Inflix. So population 1 deals with the 169 patients who received Inflix, and 75 of them were in remission, so that would be a success. So we're going to put in 169, and then number of successes was 75. Now I'm going to do the same thing for the other medication. In particular, we had 170 patients who had Azath, so that's the total number, it's our N value. And then 51 were in remission, so that's the number of successes. So we do 51 and 170. And then we're doing a confidence interval, so I check that box. And they told us 95%, so I don't have to change this number. Now if we compute, we get a confidence interval right here. And this range of numbers that you see, that's our confidence interval. The ones on the slides have just been rounded. So we rounded to 0.04 and 0.25. Okay, so that's where this confidence interval comes from. Now we can do this problem. So how do we determine which treatment is better? Well, we interpret the confidence interval. So first, we check if the interval includes 0 or not. So is 0 between 0.04 and 0.25? What do you think? Well, it's not between those two numbers, so the interval does not include 0. This tells us that we are confident that P1 is not equal to P2. In particular, we're confident that Azath and Inflix are not the same, or one of them is better than the other. Second, the values of the confidence interval are all positive. A positive value means that the proportion of people in remission is greater for population 1, or in other words, it's greater for the population who took the Inflix medication. That's the number. Remember, P1 represents the people who took Inflix, we're told that. So we're confident that P1 is bigger than P2 because P1 minus P2 is positive. Well, this means that Inflix is the better treatment. So we can say the percentage of people who will go into remission is at least 4 percentage points greater with Inflix than with Azath, because 4 is the lower, it's the smallest number in our confidence interval, 4%. That's like like the smallest difference that we think there might be, and as much as 25% is the biggest number. So it could be as much as 25% better than as-eth.